Hi everyone, I am Dr. G. Srinivas, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this present video, I would like to discuss the question bank on Module 3 of the subject DEBC, Differential Equations and Vector Calculus. And now the topic is Partial Differential Equations and it is come by Part C. Now see some examples. I will solve some more problems in the given question bank. So we'll take the second problem. Form the differential equation, partial differential equation by eliminating the arbitrary constants from z is equal to ax cube plus by cube. The given equation is the given function z is equal to ax cube plus by cube. And I have to form the partial differential equation by eliminating a and b. So we know how to eliminate the partial derivative, the constants a and b by doing partial differentiation of z with respect to x and y. So in differentiating partially the above equation with respect to x, then we'll get dou z by dou x is equal to 3ax square. By cube will be 0, that is 3ax square only, that is p. Dou z by dou x means p, and p is equal to 3ax square. Similarly, on differentiating the above equation with respect to q, y, dou z by dou y is equal to, the first term is the constant term because we are differentiating partially with respect to y, and this will be 3by square, or q is equal to 3by square, and call this is equation number 2. Now our aim is to eliminate the constants a and b from the equation capital A. Now I can write from 1 the 3a or a is equal to p by 3x square. I can write a is equal to p by 3x square and b is equal to q by 3y square. So, substituting these two in equation number A, then gives A implies z is equal to A means p by 3x square into x cube plus b means q by 3y square into y cube. Now, I am cancelling out x square, x cube, 3 cancel y square cube, then it is px by 3. And this is qy by 3 is equal to z, or the relation is px plus qy is equal to 3z, and which is the required partial differential equation by eliminating the constants, parameters kept small a and small. Just to differentiate partially, and then from the equations 1, 2, 3 or a, 1, 2, eliminate the values small a and small b, and we will get the required partial differential equations. Now similarly, form the partial differential equation by eliminating a and b from log az minus 1 is equal to x plus ay plus b. So I will solve this problem also. Log az minus 1 is equal to x plus ay plus b. So what I have to do is, here I have to form the partial differential equation by eliminating constants a and b. So the same procedure, we differentiate partially with respect to x and then with respect to y, and then we eliminate a and b. So similar procedure on differentiating partially with respect to x. Log az minus 1, 1 by az minus 1 into az minus 1 differentiation a into dou z by dou x means p is equal to 1. This is 0, this is 0. Because we are differentiating partially with respect to x, only 1 will get, it is 0, it is 0. 1 by az minus 1, a into dou z by dou x, that means p. Dou z by dou x is replaced by p. And the second equation, or I can write it as AP is equal to AZ minus 1 AP is equal to AZ minus 1. Call this is equation number 2. Similarly, on differentiating partially with respect to y, what do you get? 1 by same AZ minus 1 into A into dou Z by dou y, that is Q, 1 will be 0, is equal to, here x 0 and A into y derivative with respect to y partially 1, A plus B constant 0. Or what I can write here, AZ minus 1, AZ minus 1, AZ minus 1 is equal to AQ by A, or this is equal to Q. So what I can write from this, on equating, on substituting, or on equating these two, AP, AZ minus 1, AZ minus 1, from the two relations, AZ minus 1 is equal to Q's third equation. From the equations 2 and 3, AP is equal to Q, which is the required solution of the given partial differential equation. So we have to eliminate AP now. So A is equal to, so this is wrong. Here I write, what I can write here, AZ minus 1 is equal to AP. AZ minus 1 is equal to AQ by A. AZ minus 1 is equal to Q. What I can write here, AQ dou Z by dou y. AQ is equal by A. Or I can write this is from 2 and 3, AP by AQ is equal to, AP by AQ is equal to AZ minus 1 by AZ minus 1 into A. Am I right? Or this is AZ minus 1, AZ minus 1 cancel. AQ is equal to A. Or AP is equal to Q is equal to, call this is equation number 4. Now substitute 4 and 2. Then AP is equal to Q, that is A into Z. A means what? Q by P, Z minus 1. Or PQ is equal to QZ minus P. P into 1 plus Q is equal to Q into Z. Here there is a small doubt in this. It is AP is equal to AZ minus 1 and here it is AQ is equal to A into AZ minus 1. On equating 2 and 3, from 2 and 3 what I can write? AP by AQ is equal to AZ minus 1 by AZ minus 1 into A, or Q is equal to AP. Now substitute this Q is equal to AP in equation number 2, then Q is equal to AZ minus 1, then A is equal to Q by P. So PQ is equal to QZ minus P, or P into 1 plus Q is equal to QZ is the required partial differential equation of the given function after eliminating the arbitrary constants A and B, right? Now see another problem. Form the partial differential equation by eliminating the constants a and b from this. X minus a whole square plus y minus b whole square is equal to z square into cot square alpha. Z square into cot square alpha. So just call this is equation 1. And differentiating this equation with respect to x, 2 into x minus a and a plus 0 is equal to 2z into dz by dx. Dz by dx means it is p into cot square alpha because it is the constant. Or x minus a is equal to what? 2 to cancel. P into z into cot square alpha. This is called equation number 2. Similarly, on differentiating equation 1 with respect to y, 2 into y minus b is equal to 2z into dou z by dou q into cot square alpha. Or 2 to cancel, y minus b is equal to qz into cot square alpha. This is equation number 3. Now from 2 and 3, how to eliminate? From substitute 2 and 3 in equation 1, then what we will get? X minus a whole square, that is p square z square cot power 4 alpha plus q square z square cot power 4 alpha is equal to right square z square cot square alpha. So when cancelling out cot square alpha, z square both sides, you will get the equation p square cot square alpha plus q square cot square alpha, p square plus q square of cot square alpha is equal to 1. This is the, or I can write p square plus q square is equal to 1 by cot square. Tan square alpha is the required partial differential equation of the given function. X minus a whole square plus y minus b whole square is equal to z square into cot square alpha. So very simple, just we have to identify which equation will eliminate the constant a. That if you observe, then it is easy. So these problems, 3 problems comes under the formation of partial differential equation. Now we see some problems on the solutions. See the 4th problem. It is the solve the partial differential equation p root x plus p q root y is equal to root z. Now I will see this problem. P root x, solve p root x plus q root y is equal to root z. So what is the standard form of the linear equation? pp plus qq, Lagrange's linear equation. qq is equal to r. Clearly this equation represents this form, where capital P is equal to root x and capital Q is equal to root y. Then the subsidiary equations dx by x, p is equal to dy by q is equal to dz by r, capital Q. So dx by root x is equal to dy by root y is equal to dz by root z. And taking first two, dx by root x is equal to dy by root y, or x power minus half dx is equal to y power minus half dy. So integrating what you will get, x power minus half dx is equal to integral y power minus half dy plus c. Or what I can write, x power minus 1 by 2, x power minus 1 by 2 plus 1 by minus 1 by 2 plus 1. Here integration y power minus 1 by 2 plus 1 by y power minus 1 by 2 plus 1 plus c. Or this is 1 minus half, this is 2 into root x is equal to 2 root y plus c. Or root x plus root y is minus root x minus root y is equal to some other constant k. This is 2, c by 2. C by 2 take another constant. This is the first function. Similarly, on equating the second and third, dx by root y is equal to dz by root z, or dy by. This is dy by root y. I am taking 2 and 3 fractions, you will get this one. Or y power minus half dy integral is equal to integral z power minus half dz plus c, or c1. or y power minus half means it is 2 root y is equal to 2 root z plus c1, or root y minus root z is equal to some k1. This is the second solution, second independent solution. Therefore, the required solution, what is the required solution? Phi of or f of root x minus root y, comma, root y minus root z is equal to 0 is the required solution of the given partial differential equation. So, throughout this chapter, we follow the Lagrange's equation. So, it is also in the form PP plus QQ is equal to R. It is in the form PP plus QQ is equal to R. What is P here? 1. What is Q? 1. What is R? That is also Z. Then what is the solution? dx by P is equal to dy by Q is equal to dz by R. That is, what is the solution? dx by 1 is equal to dy by 1 is equal to dz by z. These are called the subsidiary equations. So, after writing subsidiary equations, we take first two, dx is equal to dy, or integral dx is equal to integral dy, or x is equal to y, or plus k1. Similarly, I am taking the second and third, dy is equal to dz by z, or on integrating y is equal to, on integrating both sides, integral dy is equal to integral dz by z plus k2 or k1. Then y is equal to log z plus k1 or k2, or y minus log z is equal to k1. Then what is the solution? Therefore, the solution will be function of y plus k means what? It is x minus y is equal to k. So, what we will get? X minus y first term, and y minus log z is the second term is equal to 0 is the required solution. The procedure will be the same as in the previous case problem. Here also PP plus QQ is equal to R notation. Here you can observe that capital P is equal to X, capital Q is equal to Y, capital R is equal to 1. What are the equations? dx by P, dy by Q is equal to dz by 1. On equating first two equations, log x is equal to log y plus log c1, or x is equal to c1y, or x by y is equal to c1. That is the first independent solution. Similarly, take second and third, that is dy by y is equal to dz. On integrating, what we will get? What we will get? Log y is equal to z plus c2. Or what I can write? Log y minus z is equal to c2. Therefore, the solution will be capital F of x by y first function, log y minus z is equal to 0 is the second function. So, the required solution is capital F of x by y, log y minus z is equal to 0. All are in the same model. So, this is also P plus Q is equal to R. So, just to identify capital P is what, capital Q is what, capital R is what. Then we write the equations dx by P is equal to dy by Q is equal to dz by R. So, based on that you write the solutions of the given equation. So, these all problems are similar problems. I use it to solve some problems in the given equation. So, this also you can write x plus y into P minus x plus y into Q is equal to z. Here what is P? Capital P is x plus y, and capital Q is minus of x plus y, and R is equal to z. Then what are the subsidiary equations? dx by P is equal to dy by Q is equal to dz by R. So, dx by x plus y, first one, dy by minus of x plus y, and dz by R means z. So, I am taking first two. What do you get? I am taking first two. Dx by x plus y is equal to minus of dy by x plus y. So, these two will get cancelled, or dx is equal to minus dy, or x is equal to integrating minus y plus k, or x plus y is equal to k. That is the first solution. X plus y is equal to k. Similarly, on equating the second and third, what is third? dy or first and second, first and last, you can do anyone. dx by x plus y is equal to dz by z. In equating 1 and third terms, dx by x plus y is equal to dz by z. What is x plus y? Dx by k is equal to dz by z. From the above relation, x plus y is equal to k. So I'm integrating 1 by k into x is equal to log z plus k2. Or x by k minus log z is equal to k2. So this is the second solution of the given partial differential equation. I'm writing two solutions as in the form of f of k1 comma k2 is equal to 0, which is the required solution of the given partial differential equation. So in this way you can solve all the problems. So this is this chapter has been this question bank of the course from differential equations and vector calculus, and the regulations are BT 23 and published by the Ministry of Aeronautical Engineering, Hyderabad. And so with these few problems, I conclude my session. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.